Just talked about with solving equations using addition and subtraction. So you having to add something to both sides, having to subtract something to both sides. And then you can do the same thing with multiplication and division. Whenever you do to one side, if you do to the other, it stays true. Okay? So we can use that to help us solve for variables. Again, our goal here is the same. Get the variable by itself, get it positive. Okay? In this case, it's positive. It has a 3x in front of it, but it's not by itself. So I'm multiplying 3 to the variable, right? So I need to undo that. I need to do the inverse operation. So what's the inverse operation of multiplying by 3? Dividing, right? So when you divide this by 3, okay, 3 divided by 3 is going to give you 1x. So that's good. That's what I want there. But whatever I do to one side, I have to do to the entire other side, right? And 12 divided by 3, if you have a negative divided by positive, is that negative or positive? That's negative, good, right? It takes two negatives multiplied or divided to make a positive. So the answer would be -4. And again, you can check your answer if you plug that back in. 3 times -4 is -12, and that's good, right? Same holds true for multiplication. If you had a problem like this, x divided by 7 equals 9. Solve for x. We're trying to get x by itself and positive. It's already positive. It's already a 1x up here, but it's not by itself. I need to look at what's happening to the variable and do the opposite, do the inverse. So what's the opposite of dividing by 7? Multiplying, right? Because when I multiply by 7, that's going to become 7x divided by 7. Well, 7 divided by 7 becomes 1x. Those cancel each other, right? So I'm left with 1x here, and whatever I do to one side, have to do to the other. 9 times 7, 63. I can check my answer. 63 divided by 7 is 9, so I'm good. Okay. So let's look at a few examples of those. I'm going to have you try one or two, and we'll just check answers together. So let's look at this first one. Trying to solve for x. It doesn't matter which side the variable's on, and we just want to get it by itself and positive. So I look at what's happening to the variable. I'm multiplying by -3, so the inverse of that is going to be to what? Divide by, yeah, good. It has to be -3, right? If you just divide by +3, you can do that. You can do whatever you want to both sides to keep it true. We're just trying to simplify it. But if you divide by +3, you're going to be left with -1x. And we just want what +1x is. So since I divide the right side by 3, I divide the left side by 3. Negative divided by negative, +5 equals x. Right? We get that one? No problem? Good. Okay, if you plug that back in, -3 times 5 is -15. I can check my answer. This one's a little different. Okay, I have just a negative sign out front, right? I have it out front. It really doesn't matter where it is, but it's out front. So I have negative x divided by 2, or x over 2 equals 20. I want to get x by itself and positive. Anybody want to take a shot at what I should do here?
Yeah, you did.
What is? Oh, it did. Sorry, I'm sorry. Yes, thank you. No, sorry, my fault. I have negative x divided by 2 equals 10. So how am I going to get x by itself here? Yeah. Good. Very good. Okay, so if I multiply both sides by 2 here, okay, 2 divided by 2, that's going to cancel. Okay, I'm left with 20 over here. What am I left with on the left side here then? Right, I'm left with -x. Okay, so you can do it. We've made it simpler here at this point, and that's like a -1 times x, right? We just don't write the 1 in front of the variable. So what could I do to get rid of this -1 in front of the x at this point? Since it's -1 times x, I could. Well, good thought. So if I add 1 to each side, if I add 1 here and add 1 here, I can't add these together though because they're not like terms. So that's still true, but that makes it a little bit more difficult for me. Yeah.
If it's a -x, then you do its opposite. So
that's true. That is true because I want to know what positive x is. So if I have the negative here, x is going to be the opposite of this. X is going to be -20. But how would that look algebraically? How could I get rid of this -1 in front of that x? Since it's -1 times x, what's the inverse of multiplying? Dividing, right? If I divide this side by -1, that's going to leave me with positive x. And if I divide this side by -1, 20 divided by -1 is -20. That would be my answer. But, so that's a perfectly good way to do it. But let's go back to the very beginning. Is there a way I could do that all like in one step where I didn't have to do it in 2 steps here? Yeah.
you multiply by -2.
Very good. Good. If you multiply by -2 here, the 2's divided by 2 is going to cancel, but the negative times a negative, like a negative times a negative is a positive, right? So that's going to leave me with positive x there, which means I multiply by negative 2 on this side, and I'm left with negative 20. Either of those ways is fine, but you can do it all in one step if we multiply by negative 2 there. How about this? I have 1/3 x equals 2/5. I want to solve for x here. Thought process is still the same. Get x by itself and get it positive. What can I do to get it by itself and positive? So let's look at what's happening to x. I have 1/3 times x. That's a multiplication. So the opposite of multiplying something is, of course, dividing, right? But I need to divide by 1/3, right? Divide by 1/3. When you divide a fraction, that's the same thing as doing what? Multiplying by reciprocal. Very good. Remember, reciprocal is a flip. So dividing, if you divide both sides by 1/3, that's the same thing, and it's a lot easier to work with as multiplying by the reciprocal. Because when you multiply by the reciprocal, that's going to become 3/3x. And 3/3 is just 1x. So whatever I do to one side, I have to do to the other. 2 times 3 is 6. 5 times 1 is 5. And that's a perfectly good way to leave it. If you wanted to change it to 1 1/5, you could. So whenever you have a fraction in front of the variable, if you multiply by the reciprocal, which is the same thing as just dividing the fraction, you can get it so there's just a 1x there. Okay. About this, 4 1/3 y, 4 1/3 times y equals 6. I want to solve for y. I want to get y by itself and positive here. So I know that's 4 1/3 times y, so I could divide both sides by 4 1/3, but the question is, how does that look algebraically? Divide. Okay. What would be something I could do here to start simplifying this? Yeah.
Put it into a mixed number.
Yeah, very good. I would put it into an improper fraction from this mixed number. That way it just becomes a fraction with the numerator and denominator. So remember to do that. You take 4 times 3, which is 12, plus 1, which is 13. So now it becomes 13/3y equals 6. Okay. Now, just like we said before, this is like 13/3 times y. So I need to undo the inverse operation. I need to divide both sides by 13/3, but dividing by 13/3 is the same thing as doing what? Very good. Multiplying by its reciprocal, right? Because this is going to become 39/39. And 39/39 just leaves me with 1y, which is what I want. And whatever I do to one side, I have to do to the other. So 6 isn't a fraction yet, but I can just put it over 1. That way it makes it easy to multiply. 6 times 3, 18. 1 times 13 is 13. I could simplify that to 1 5/13 if I want, but I'm fine leaving it improper as long as it can't be reduced. Okay? And that would be my final answer.